Pascal's principle comes from Blaise Pascal, the same person that the unit of Pascal is named after, states that when a change in pressure is applied to an enclosed fluid, that change is transmitted undiminished to all portions of the fluid and to the walls of the container. Let's look at an example here. Here we have a weight resting on a fluid, so that weight is exerting some force on the fluid equal to mg. We can then say the pressure that comes from that is that force over the area, or mg over A. At the bottom of the fluid then, we would have that pressure that's at the top plus rho gh. Pascal's principle doesn't say that the pressure is the same everywhere in the fluid. It says that when we change the pressure anywhere in the fluid by, for example, adding this big mg on top, now we have a new pressure on top that's the previous pressure plus the big mg over A. It says that when that happens, we get an equal change in pressure everywhere in the fluid. So our new pressure at the bottom will be whatever it was at the bottom plus that mg over A. The change in pressure at the top is mg over A. The change in pressure at the bottom is mg over A. These are the same. That's Pascal's principle. I've sometimes heard it called Pascal's law, and it's essential to the functioning of hydraulic systems. Let's look at one. Here we've got some pistons and some confined fluid where you've got a pressure over here and a pressure over here with different areas on these pistons. Pressure is equal to force over area. So for this piston, our pressure is equal to force over area. And for this piston, our pressure is also equal to force over area. What Pascal's principle says is that when we apply some force over here, it gets transmitted over to this other one. And that change in pressure is going to be the same. If we don't have a height difference, then the pressure will be the same. As we increase the pressure over here by putting some additional force there, our pressure increases over there at pressure 2, and we get some output force coming out. That's the basics of how hydraulics work. This lets us relate them by saying that because the pressures have to be the same, now the force over the area on the input piston is equal to the force over the area on the output piston. This tells us that we can get an output force that's bigger than our input force, proportional to the ratio of the areas. If you have an area that's 10 times your input area, you'll get 10 times the force out. How does that work? Isn't that like cheating? Well, yeah, it's cheating in the same way mechanical advantage or pulleys or any of that stuff is cheating. And that, yes, we can get higher forces, but we can't create free energy. Energy doesn't come from anywhere. It just changes forms. You don't get free energy. What ends up happening is as I push down here, yes, I get more force coming up here, but that means for a given amount of work, I have to push farther in order to get the same amount of work coming up here. So it's kind of like gearing in that case, right? You can spin a whole bunch and then gear it up so that it spins a little bit, but with much higher torque.